You heard us talk all about the 3D printing lingo. Now it's time to talk about the machines. Let's get back to basics. Thank you so much for joining us, and hey, learning about different types of 3D printers, get subscribed so you can get more awesome content like that coming at you. Hey, leave us a like too. Helps our channel grow, and I know we hate it when creators say it, but it works, so sorry. Let's get into it. There are lots of types of 3D printers out there, and I know I'm going to gloss over quite a few of them. That's deliberate. This is a back to basics video. If you guys want me to go into detail and really talk about some of these processes, both from a user standpoint, because I've used a lot of these processes, as well as a sales standpoint, even further from a Grant rant standpoint, because boy, I have some opinions on some of these techs. Happy to do it. Let me know in the comments. But let's start with kind of the new big dog in town. SLA, Stereolithography Additive. Just don't ask. SLA was the first type of 3D printing ever invented. It was invented by Chuck Hull in the 1980s, officially filed the patent in 1984, granted in 86. Florida's the first to file state, so I say 84. That way I can also make a George Orwell joke, so there. But Chuck Hull invented this technology that is becoming more and more popular because of the price of screens used in masked stereolithography have come down. Now, there are a few different types of SLA. You have your standard SLA, which is laser source, mirror, vat of resin, and that laser can, selectively cure points on that resin vat, or MSLA, which is the most popular right now, where a screen, an LCD screen actually, either allows light to pass or doesn't allow light to pass, so it's clear or not clear. And under it is a UV light source that cures an entire layer at once, making MSLA relatively fast. We also have an antiquated one called DLP. It is somewhat still used, especially in companies like Envision Tech, but we are seeing it on the decline as the cost of these high-resolution, smaller screens gets really, really affordable, making masked stereolithography, MSLA, more viable. SLA is probably one of my favorite technologies right now because it has gotten so affordable. You can actually get a decent resin printer for less than $300. And if you're wondering, Grant, what printer would I get for less than 300 bucks? That seems too cheap. Card to that video. Enjoy it. It's a cool one. SLS. Selective Laser Sintering. SLS is kind of the base of a lot of these high-end technologies and where a lot of companies are moving toward, because similar to their screens, the laser sources, which are normally fiber in nature, fiber lasers, not the fiber that keeps you regular, but a fiber laser, the prices on those are coming down considerably as well. Machines like the Fuse 1 from Formlabs, yeah, we all didn't think that was ever gonna happen. We're gonna cover that in a future video, don't worry. I have some opinions on Formlabs, but SLS has been kind of the player. Most of the time, we as consumers and prosumers cannot touch it with a 10-foot pole. Even the Fuse 1, which is considered a more affordable SLS printer, is like 20 grand. There's the Sintering Lisa and the Lisa Pro. Those are as low as like 8 grand. But even then, that's really expensive, and the Lisa and the Lisa Pro are leaps and bounds worse than a Fuse 1. I think a Fuse 1 is actually a reasonably decent value. But the cool thing with SLS is that it prints in powder. It is actually powdered nylon. There is a enclosure. There is a powder substrate, nylon, metal, whatever it might be. It is heated to within a few degrees of its melting temperature, and then the laser goes pew, 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 and selectively laser sinters the thing. It's so cool. It's so cool. I love SLS. It's one of the coolest technologies to watch, honestly. Like, a clear SLA is a cool technology to watch, but SLS is just like laser beams doing laser beam stuff. They're invisible lasers, so you don't get to, like, play Star Wars music in the background, but it's still cool. SLS is really where a lot of the industrial printers are moving towards. So anyone that is really taking the service side seriously and has a little bit of cash to burn, they are looking at getting SLS machines because their throughput is pretty high. The material is incredibly affordable and the reuse rate is okay. Powder printers have a reusability rate. You can't just take all the excess SLS powder and reuse it over and over again. Because you are heating it so close to its melting temperature, you're actually degrading the powder. And then when you hit it with the laser, of course, it's going to radiate heat out into the surrounding powder. So normally you want to mix at least 40% virgin material into your already used material. So you're always doing a bit of a turnover. So just be aware of that. But nylon powder is incredibly affordable. We have nylon, which is the most common form of selective laser sintering, but there is also DMLS, EBM, and a few others that are involving metal 3D printing, a powdered metal 3D printing. Let's be specific about that. Powdered metal 3D printing is awesome, but very much a NASA-based process. It either works or it tends to get a little fiery and dangerous. And of course, very expensive. Titanium powder, last we checked, and this was years ago when we were actually pricing out DMLS printers, was $614 a kilogram cost. So you can only imagine what it's gone up to now. As well as, gosh, printed parts in it, I can't imagine what their price is. If you have to ask, you probably can't afford it. But the technology is vastly available to aerospace and those kind of adjacent engineering high-end industries where they don't really care what it costs, they just need it to work. And when you're looking at sending something into space and space-related territories, you kind of need metal 3D printing. Inconel being one of those awesome materials. What's up, SJ? DMLS is one of the big drivers right now in aerospace, but SLS as a whole, selective laser sintering material as a whole, is the biggest driver for the industrial grade. Something just to be aware of. Let's move into technologies that we all understand, and then we'll get into some of the cool ones too. FDM. Fused deposition modeling, fused filament fabrication, the computer-controlled hot glue guns that you sometimes see running behind me when we do decide to run them when we are recording. FDM is an awesome technology. It is incredibly affordable because you don't have to spend a lot of money to get good value. I mean, seriously, like, I kid you not, we have one right here. You can get a freaking Prusa Mini for $400 plus, yeah, some upgrades. You're less than $500 for a crazy comparable 3D printer that is going to punch way above its weight class. Let me set that down. If you got a little bit more of a budget, the Mark III S from Prusa is an amazing 3D printer at less than $1,000. Honestly, they're worth it. You can look at getting something like the Elegoo Neptune 2, which they're coming in and out of stock on Amazon. They're like a $165 FDM 3D printer or even a Ender 3, but they're valuable. And a lot of people that joined us through the Cricut debacle are now looking to add these 3D printers to their spaces. And some of them already have. And we're getting all these great emails about how they're using them, how they're really looking at how a 3D printer can be valuable. And I freaking love that. But there are some styles of FDM. I'm going to list them real quick, and then we're going to talk about them. There's the standard Cartesian, like you see behind me. There are Deltas. There are CoreXY, CoreXZ, HBot, the Polar3D, and SCARA, to name a few. There's the Monorail printer as well. That one's kind of cool. Billy Rubin actually interviewed the guy that did the Monorail printer. We'll card up to that video in her Meet the Maker series. It's amazing, and hey, if you didn't know, I was interviewed on Meet the Maker as well, so editors are gonna hate me, but we'll do another card because we can. But there are so many options for FDM 3D printing, and these all kind of come down to the motion platform. A standard Cartesian printer, XYZ, right? Your hot glue gun duct tape to an Etch-a-Sketch that also moves in a Z-axis. Delta printers are based off of pick-and-place machines. They have 3 arms. I only have 2, so friggin' work with me here. But they have 3 arms, and based on where those arms are positioned up and down, their lengths will change, which moves what is called the end effector. The end effector has a hot end on it that allows it to move. In my opinion, Deltas are some of the prettiest 3D printers to watch because they can not only move incredibly fast, but they're very elegant. The arms don't have to move a ton to see your hot end go like this. The arms have to move maybe like 2 or 3 inches to see an 8 or 9 inch movement because of a lever arm. It's so cool to watch. If you do want to see some in-depth talking about deltas, let me know. I will happily get a delta and talk about some of the cool factor about it, but also where they're very complicated, especially for beginners. We have CoreXY. CoreXY, we actually built our own CoreXY 3D printer. We call it colloquially the big ass D-bot because it is a big ass D-bot. It is 400 by 400 by 788 millimeters. That makes it 16 by 16 by 31 inches. Yeah, the definition of huge. This is a 31-inch tall 3D print. Look at this thing, it's huge. It's huge. This is how big the D-bot can make parts. It's crazy. I promise it's worth it. Building your own 3D printer is a ton of fun, but get a little experience in it before you do. Big freaking 3D print. Yeah. This was, there's a fun story behind this. Let me know and I'll do a video about the story behind this Christmas tree. But just let me know in the comments if you want to hear it, and we will do a little short video about the story behind this crazy 31-inch tall Christmas tree that is completely hollow. CoreXY is awesome because it evens out all of the stresses involved in the motion platform. So normally you would turn one motor and an axis moves in one direction. In a CoreXY, you turn one motor and the print head moves 45 degrees. And that is because everything is consistent. So when you're moving it, it allows you to move so much faster without causing degradation on the belt motion platform. The print bed only moves vertically on the Z-axis instead of just your X-axis moving in the Z, as well as, I guess, technically the E-axis. But on Cartesians, you're moving a lot more weight sometimes, right? You're moving a lot more mass more often than you are on a CoreXY. On our big D-bot, the bed alone weighs over 20 pounds. But I promise it's worth it. It's so much fun. There is also CoreXZ, which I think is a Deltesian. And one of our good friends, Rob, actually really designed the Deltesian, where it uses effectively 2 arms from a Delta printer plus the Y-axis from a Cartesian printer. The arms provide the positioning of the tool holder on the X and Z axis, and the moving print bed provides positioning along the Y. This does allow you to actually make some really big parts with a CoreXZ motion setup. And the H-bot is similar to a CoreXY. It's actually what a CoreXY is built off of, but it involves belt crossing in the back versus belts running parallel to each other in the back. Then there's a Monorail printer, which, no, nothing to do with Disney, but as you would expect, has a single rail. And similar to a Delta printer, it utilizes 3 arms interacting at different levels to create a movement. Then we get into Polar3D. Polar3D is similar to a SCARA arm, and a SCARA arm, I gotta scoot back for this one. A SCARA arm is like if your arm, I'm gonna hold a hot end, was a 3D printer, right? It can move here, it can move here, right? So it has full motion control. Now, a SCARA joint will go past 180. It'll probably go near 270. But so SCARAs can operate within a round platform given their drawing space. SCARAs were originally used in the television industry, where they were used to move tapes up and down inside of what is now basically a big hard drive. That's at least how we know it. But back then it was all on tapes, and they had to move these tapes around very quickly, and SCARAs are perfect for that. Polar3D utilizes similar to a SCARA, however, they use a smaller arm and the platform itself also rotates. Joanne Fabrics actually cleared out a ton of Polar3D printers recently for like 200 bucks. Andrew Sink did a gorgeous video. We'll have a link for it in the description down below where you can check out his review on the Polar3D printer, because honestly, it's kind of cool. Then we go into some of the cooler technologies that are a little bit obscure. One of them being X1. X1 is a metal-ish process. So it uses a powder bed of metal, but it's a cold process where they initially do binder jetting, which is just a fluid that holds everything together, right? A glue, if you will. And then the part is put into an oven where it is infiltrated with bronze. So you end up with like a steel or bronze mixture. They're really cool parts. They're about 90% the density of a solid metal part and reasonably close to the strength of DMLS, but not as strong. Great if you need to do very, very fast metal prints that are very large, where DMLS may not actually work all that well. PolyJet. PolyJet is an awesome process. If you saw our video on the Stratasys truck, then you will have seen PolyJet. But PolyJet is exactly what it sounds like. It's a bunch of really tiny jets that squirt out material, and then a UV light cures it. If you've seen the movie Kubo and the Two Strings or any of the more recent movies from Leica Studios, you have seen PolyJet at work. If it was before Kubo and the Two Strings, so like Paranorman and the Box Trolls, you actually saw CJP. We'll get to that in just a minute. But PolyJet allows for every color under the rainbow, period. Stratasys has such a wonderful makeup of colors, of materials, and as much as I will constantly crap on Stratasys for the really bad job they've done with MakerBot, I think that even though they've raised the price of PolyJet to be way too damn expensive, that it is still an incredibly valuable technology to the industries that see the value. Objet used to really own this technology, but Stratasys bought them out years ago. And they've really worked on building this technology, which is good because historically speaking, when small companies get bought out by big 3D printing companies, they're generally just shelved and told to take your money and go away. They don't end up doing anything with it because they don't want that tech to become a competition. So instead they just shelve it, which is a shame because it really doesn't help the industry grow. But at least for PolyJet, Stratasys went the complete opposite route and said, no, we want to pursue this. And I think honestly, they've done a great job. When you can get a PolyJet printer for like 40 grand that makes beautiful, gorgeous parts, there's a lot of value in that. To a company like 3D Musketeers, not right now. 40 grand is way more than we're willing to spend on a machine like that. If those nozzles clog, you have such a problem to deal with. And they can clog if you don't run your 3D printer. It's interesting. When you get into these industrial grade 3D printers, the more you run them, the more reliable they are. If you allow them to sit, the binder dries up, the machines, their lubricant dries up, the powder sticks to things it shouldn't stick to. It's a nightmare, but still valuable. There's also sand binder jetting, which is similar to X1, but instead of a metal powder, it's a sand powder. And it's either like plaster based or PMMA in conjunction with a liquid binding agent. The printer first jets on that binding agent, and then a second print head will then come and jet on the color. That is more specifically in the CJP ColorJet printing side. The sand printers specifically are not about color. They're about getting a usable model very, very quickly. And sand, because of its silica-based porous nature, is incredibly easy to do binder jetting with. Then we get into CJP, a technology called ColorJet printing that is incredibly near and dear to my heart. It is actually what I cut my teeth on in this industry. A lot of things you all may not know about me is how I started. I actually started in a completely different business. I owned a company called The Object Shop along with a partner, and we really worked on being the best in the industry for full color 3D printing. I was the guy in charge of those machines, and I did all of the work. And we worked with people all the way from the Smithsonian, and eventually in 3DM, we actually worked with Snoop Dogg. And so we've had wonderful opportunities to work with people from many different walks of life, and CJP is what brought it all together. ColorJet printing is so bloody simple, yet so bloody complicated. The machines, for all of you computer geeks out there, run DDR RAM. Yes, not DDR4, which is what we're currently using, or DDR5, which is used in graphics cards, but DDR. And it had 128 megabytes of that. We actually would buy half gig sticks of DDR RAM and put it in there, and the machines would run so much better. Their processors were so slow, they were passively cooled, and their hard drive was a compact flash card. No, not CFAS, Literally compact flash. Slow as all sin, but you know what? They worked. CJP was first developed by Z-Core many, many years ago, and it took off to a point where 3D Systems actually bought it in 2011. Now, I've ran both Z-Corp and 3D Systems machines, and they're literally the same, other than 3D Systems changed the color of the exterior case. These machines are literally inkjet printers. They use HP C4810A printheads, and they just use big bottles of ink. Now, this was not ink from HP. The ink was primarily a sugar, water, and alcohol mixture with a pigment colorant, and that was always a bit of a problem because the deltas on them were like double digits, which is crazy. You want deltas like sub 1. These were double digits of deltas, and delta is your difference in color. When we would be doing this on a production level, it was a pain. But man, when you ran these machines, we found ways to make these machines work so well. And to this day, we can still run with the big dogs. We still have one here at 3D Musketeers. It is actually for sale. So if you want to get into ColorJet printing, I would actually train you and warranty the machine for labor, which I would train you how to do, for 6 months. You can make your money back on these machines very quickly if you know what you're doing. But they are primarily used for very fast model printing, specifically in the figurine market, where we could take a 6-foot-tall person, scan them in, print them out in a day or less. Very, very fast. And because it does every layer at once, you can fill the entire XY platform of these machines, and it doesn't take that much longer to 3D print. However, like most binder jetting processes, it purges every few layers, so you want to pack as many parts as you can. I got really good at 3D Tetris throughout the years. But ColorJet printing is it's very near and dear to me. I'm going to talk more about it on our live stream coming up this weekend, so make sure you get subscribed for that. And as always, guys, I appreciate you being here. It means a lot to us. We are coming up on 1,000 subscribers, and we're going to be doing a giveaway for some of Brad's orange from Printed Solid. I'm excited for this. We never thought that YouTube was going to take off the way that it did, and I am thankful for you all. We're going to do a live stream when we're getting close to 1,000 subs, so you can watch it along with us. I just want to thank you guys for participating and supporting us through this crazy journey. I'm not going anywhere, at least not voluntarily. Hopefully you learned something amazing in this video. If you did, let us know in the comments below what your favorite technology is. And hey, maybe I'll do a deep dive into it if you convince me. Likes help with that, by the way. Anyways, guys, stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. Have a good one. Oh, excuse me. Good thing that wasn't in there.